Okay, so today in pharmacology we are going to look at drug calculation. Now, when it comes to drug calculation, we'll start first of all by looking at some conversion, how we can convert, for example, something from kg, how we can convert something from kg and we take it to grams. Apart from that, we can convert something from grams, we take it to milligrams. Then apart from that, we can also convert something from milligrams and we take it to micrograms. Because when you understand about how to convert these things, you find that certain drugs, you need to take them to micrograms for you to be able to calculate and find the correct doses. So this is what we'll start with. Then we move on to examples of some drug calculations, and also we'll talk about calculating for infusion of fluids, and then I think from there it will be okay. So when it comes to conversion, for example, we can start with trying to convert 1 kg, and this 1 kg we are taking it to grams. So now, how do we convert a 1 kg to grams? You need to know that what makes up 1 kg is 1000 grams. So what makes up 1 kg is for you to have 1000 grams. So when you multiply 1 times 1000, meaning you get 1000 grams. Apart from that, having known to say 1000 grams makes up 1 kg, it means that we can also try to know how to convert a gram to milligram. So again, when we are trying to convert 1 gram to milligram, you need to understand that what will make up 1 gram is for us to be able to have 1000 milligrams. So when we have 1000 milligrams, this makes up 1 gram. Now, we also need to know how to convert milligrams to micrograms. And here again, you need to understand that what makes up 1000 microgram is what makes up 1 milligram. So when you have 1000 microgram, this makes up 1 milligram. So if you are trying to convert from microgram to milligram, if you get 1000 milligram, it shows that you have 1000. If you get 1000 microgram, it shows that you have 1 milligram. If you have 1000 milligram, it shows that you can have 1 gram if you are going in reverse. Then if you have 1000 grams, it shows that this is equal to 1 kg. So in terms of the conversion, this is how you can convert from one particular SI unit to the next particular different SI unit. Now we can talk about maybe, for example, a particular example of how we can do the conversion. Let's take, for example, you have been given atropine. Atropine 0. So you have been given atropine 0.6. Atropine 0.6 milligrams. So having been given atropine 0.6 milligrams, then we ask you to say how much is 0.6 milligrams in micrograms. So now, how do we convert 0.6 milligrams into micrograms? How much is it into micrograms? So you are just going to say 0.6 multiplied by 1000, because we understand to say 1 milligram is made up of 1000 micrograms. That's why we are multiplying it with 1000, and at the end of the day you're going to get 600. You're going to get 600 micrograms, meaning if you have 0.6 milligrams, this is equal to 600 micrograms. So having 0.6 milligrams, this shows that you have 600 micrograms, and this is what we are talking about in terms of conversions. Okay, we can look at another example. Let's take another example. Says you need to convert what can we talk about? Okay, let's just say the example says you need to convert 0.01 grams, and this one you need to convert it to milligrams, meaning how much in milligrams is 0.01 grams. Meaning again here what you are going to say is you say 0.01, you multiply it by 1000, because you understand to say what makes up 1 gram is 1000 milligrams, and that's why we multiply it by 1000. So when you do this multiplication, you end up getting 10, and this is 10 milligrams. So when you have 0.01 grams, this is equivalent to 10 milligrams in that particular manner. Okay, so let's look at the last example in terms of conversion, then we can move on to the next step. So let's now do the reverse. Let's try to say, let's take for example, you have been given gentamicin. 360 milligrams, and then they want you to convert it to grams. Remember, grams, okay, let me change the pen. Okay, remember, grams are bigger than milligrams. So this time we are converting something with a smaller unit, taking it to the bigger unit. The previous example we are from doing, we were converting the bigger unit, taking it to the smaller unit. But now we are dealing with a smaller unit, taking it to a bigger unit, and we are converting something in milligrams, and we are taking it to grams. So now, and we are saying we have been given 360. We have been given 360 milligrams and take it to grams. How do we do this? You are going to say 360 milligrams, because now we are taking something smaller to take it to a bigger SI unit. Here we are going to say divided by 1000 milligrams, because we understand to say what makes up 1 gram is 1000 milligrams. Now, because we want to take the smaller unit to a bigger unit, this time we are not going to multiply, but this time we are dividing, because our answer needs to be in grams. That's why we are dividing here. We are dividing. So here you are going to find that your answer is going to be, when you do the calculation, at around 0.36 grams. It means at this particular point we're able to tell to say, if someone has 360 milligrams, this is equivalent to 0.36 grams. And that is how we can convert also a smaller version to a bigger SI unit version, or a bigger component, or bigger number. Okay, so having looked at that, we can move on to the next example, having looked at some few examples of conversion. Okay, so now let's take, maybe the scenario reads, a patient requires 4 milligrams. So a patient requires 4 milligrams. So we can still consider this as the prescription or doctor's order. Then we are saying a patient requires 4 milligrams of morphine to be given IV, and morphine is available as 10 milligrams per ml. And the question is, how many mils will you draw up to inject the patient? So this is the presentation, and this right here is the doctor's order or physician's prescription, or how much the patient needs to be given in milligrams. But our answer is in mils, because when you're injecting this as IV, it needs to be given in mils, meaning how much are we going to give in mils. So the formula is dosage. You can say doctor's order or physician's order or whatever language you use, then divided by presentation. Then this you multiply by the volume. So now, okay, so let me just do this and write the formula properly so that you're able to follow. So don't forget those figures that I've given you. So when it comes to the formula, I said dosage. Okay, so I say the dosage equals to doctor's order divided by drug available, which is also presentation, multiplied by the volume. So the doctor's order, we said the patient, what the patient requires is 4 milligrams. And here we are saying the presentation of this morphine is 10 milligrams, which is the drug available. And the volume, the question said it is 10 milligrams per mil, meaning our volume becomes 1 mil in that particular manner. So now when you do the calculation, when you say 4 divided by 10, you are going to end up with the answer of 0.4 mils, meaning this is how much you are going to give to the patient based on that particular scenario. Okay, so let's look at another example on the same, so that we can do maybe 2 or 3 examples, then we move on to the next stage. Let's take for example, maybe the patient has been prescribed 360. The patient has been prescribed with 360 milligrams of gentamicin. Then apart from that, gentamicin is available as 80 milligrams per 2 mil. Gentamicin is available as 80 milligrams per 2 mil. And the question is, how many mils will you draw up to inject the patient? As usual, here still the formula will be doctor's order equals, dosage equals to doctor's order. Then apart from doctor's order, you talk about the drug available times the volume. So now here we are being taught to say the doctor's order is to give 360 milligrams. And then the drug available, the presentation, it comes as an 80 milligrams vial or whatever. And then the volume is this 2 mils, which is here, meaning your volume becomes 2 mils. So here when you do the calculations, you're going to find that basically what you need to inject into the patient is 9 mils when you do the calculation. So this is also how you can calculate this particular drug. Then apart from that, let's look at another example on the same. Maybe we do some more examples and then maybe you may get the concept. Let's take apart from that, maybe the patient has been prescribed with haloperidol 3 milligrams IV, and haloperidol comes in as a 5 milligrams per 5 mil. So we are saying haloperidol 300 milligrams is prescribed. So haloperidol 3 milligrams rather is prescribed, and then the presentation, it is a 5 milligrams per mil. So now what is the dosage? How much in mils are we going to inject to the patient? The formula still remains the same. Dosage equals to doctor's order over drug available times the volume, like that. So here we are being told to say the doctor has ordered 3 milligrams to be given, but the presentation of this particular drug comes as a 5 milligram, and the volume is 1 ml, and the volume here is 1 ml. So again here, when you do the calculation, you say 3 divided by 5 times 1, you'll find that in mils, the amount of drug or dose that you're going to give is 0.6 mils. So this is how you can calculate drugs, but this information you're going to find it on the drug itself. You'll find that the drug will come with a presentation, and it will come with how much in fluid should be reconstituted with that drug, and then the doctor's order you'll be given as per prescription or as per what the patient needs to receive during that particular period. So this is some of the examples that we can do on drug calculation. What other example can we talk about? Maybe let's take, for example, benzyl penicillin. Is it benzyl penicillin, which comes in mega units? So maybe let's take, for example, the doctor has ordered to give 2 mega units, and then apart from that, the presentation of this particular drug comes as a 5 mega units, and it is reconstituted by 10 mils. So meaning here now the question is, how much in mils are you going to give? So again, because the SI units are the same in that particular manner, you are going to say doctor's dosage equals to doctor's order over drug available times the volume. So here again, the doctor has ordered 2 mega, and then the presentation is 5 mega, and here the volume is 10 mils. When you do the calculation, you can say 2 multiply by 10, that is 20 divided by 5, meaning your answer is 4 mils. So in mils, the amount of drug that you're going to give is basically 4 mils, meaning this is the amount of drug you're going to give to the patient by using the same formula of drug calculation. Okay, let's move on to the next part and talk about some fluids as well. So let's talk about some administration of fluids. Let's take, for example, 1000 mils. Let's take, for example, 1000 mils needs to be given or infused to the patient over a period of 12 hours. The question is, how many or how much of the fluid should be given per hour. So remember, this amount of fluids, which is 1000 mils, needs to be given in a period or space of 12 hours. But how much should we give in a single hour of these particular fluids per hour? So what you just need to do, this is not something hard. What you just need to do is say 1000 mils divided by 12 hours. When you do this division, you'll get maybe something as 83. So this is 83 mils per 1 hour. So meaning, if you're told to find how many fluids or how much or volume of the fluids you're going to give per hour, you are just going to divide the number of fluids divided by the amount of hours you're supposed to give that particular or those fluids. Then you get the answer of the fluids you're supposed to give per hour, meaning about 83 mils of fluids should be given per hour. When you multiply by 12 hours, you'll go back to the 1000 mils. Another example, let's take, for example, 1 liter. Let's take, for example, 1 liter bag is supposed to be infused over a period of 6 hours. And the question is, calculate how many meals per hour the patient will receive. How many meals per hour the patient will receive. Remember, 1 liter is equal to 1000 meals. So you can simply say 1000 meals divided by 6. So when you do that division, you'll find that you arrive at an answer of 167 when we round off. 167 meals, and this is being given per 1 hour, meaning per hour the patient will be receiving about 167 meals. Okay, maybe we talk about the last example, then we talk about the flow rate or infusion rate, then we can end there for today. So when it comes to the infusion rate, let's take, the same infusion flow rates per hour or whatever time frame is given. Let's take the example says, how many meals per hour would a patient receive if they were to have 500 meals of fluids to be given over a period of 60 hours. Again, here you're just going to say 500 meals divided by 6. So 500 meals divided by 6, and when you do the calculation, how much are we going to get? You'll find that you are giving about 83 meals per 1 hour. So you are giving about 83 meals per 1 hour. So that is how you can determine the infusion flow rate of the fluids to be given per hour if they have been prescribed for some several hours. Okay, we can now talk about the drop rate. Remember, the drop rate is used when you are giving fluids through an IV intravenously, and then if, for example, the patient is being given 500 mils, you need to determine how many drops in a minute should we see in the infusion line for us to know that these 500 mils will run for the next 5 hours or for the next 1 hour or for the next 30 minutes. And that is what is termed as the drops per minute or infusion calculation. So when you are told to calculate for the drops per minute, the formula is that drops per minute equals to total fluids or fluids in mils. So this is total fluids, or simply you can say fluids in mils, then divided by time. Let me do this. I rub this side. So I said you can say drops per minute equals to, so drops per minute equals to fluids, total fluids, or simply fluids in mils. Then you divide this by time in minutes. You divide this by time in minutes. Then you multiply by the drop factor. So the drop factor, you find it on the giving set. Maybe if you're administering fluids, it may say the drop factor is 20. It may say 20 drops per minute, or if you're giving blood, rather, it may say the drop factor is 15 drops per minute. Those drop factors, you get them on the fluids themselves. So let's look at an example. Let's take, for example, the patient is supposed to receive 1000 mils of fluids, and these 1000 mils of fluids should be given over a period of 8 hours. So this should be given over a period of 8 hours. And then we find that, these fluids we are giving is normal saline, for example, and the drop factor is 20 drops per minute. So here you are going to say 8 hours, but remember we said in the formula, we said it is time in minutes, meaning you need to multiply by 60 minutes so that we convert the hours to minutes. And then the drop factor, because we know that maybe we are giving Ringer's lactate, normal saline, or whatever, and the drop factor becomes 20 drops per minute. If it's blood, likely it will be 15 drops per minute. So when you do the multiplications, how much can we arrive at? When you multiply 8 times 60, we start by converting the time to minutes. You find that you're going to get 480. So we are going to say this should be 1000 on top. So you are going to say 1000 mils divided by 480. That one will give you about 2.1 or just 2. Then when you multiply 2 by 20, you are going to arrive at an answer of 41.6. So you are going to round this off to a block figure as 42 drops per minute. Meaning when you put up the IV line, you need to count about 42 drops in 1 minute. This will mean that if you are able to give 42 drops in a minute, at the end of the 8 hours that the patient is supposed to take these fluids, you would have given 1000 mils. So this is what it means. I will repeat the statement. If you calculate the drops per minute, and when you put the IV line, you find that the fluids are dropping, they are 42 in 1 minute. It means that if you give these fluids 42 drops per minute in a period of 8 hours, in which the patient is supposed to receive these fluids for 8 hours, when you add these 42 drops in each hour until you reach hour number 8, you would have given the amount of fluids, which is 1000 mils. So this is how we calculate the drops per minute in terms of calculation of fluids, as well as drug calculation, because sometimes certain drugs you need to give them through IV and will be pushed into the fluids being administered. So in terms of drug calculation, this is where we'll end, but drug calculation involves using this same formula, but there's sometimes where you need to multiply with the age of the baby, especially if you are giving drugs in children, meaning you multiply the dose with the age of the baby and the rest becomes the same, because in children drugs are given per kg body weight. So whatever the dose is prescribed, you multiply that particular dose with the age divided by the presentation times the volume, then you get the amount that is supposed to be given to this particular child. So for today, this is where we are going to end. Thank you so much for taking time to go through this particular lesson. Hopefully it has helped a bit. Thank you. Till next time. Bye.